So counters and timers are brothers, okay? And they're brothers because they have the same DNA. Observe here on this counter file that the counter has a file type. It's C for a counter, right? It has a file number, in this case 5, and then it has a counter number, in this case 3. So, and they are, word-based instructions, just like we said before, right? This is a 16-bit counter, right? Count 0 through 15 decimal, or 00 through 1111 binary, or you can also say that in hex, which will be 01101000, right? So whatever you want to do. So they have multi-words that are necessary for the counter to work, right? So the internal use bits are based on word 0. That means they have allocated 16 bits. The counter up, counter down, don't bit, overflow, unable, and so forth. And then the preset value also is the 16 word count, and the accumulated value it is. So question to pick your brain. You might not have the answer, but at least you can think about it. Why do we have a full word, and that is 16 bits, just to preset a value or to look at the accumulated value in a counter? I mean, why will you waste 16 bits on presetting a value or an accumulated value? Any ideas? Okay, so here's a big hint, right? The maximum count a digital device can count is limited by the number of bits, right? So if I tell you, okay, this device is a 2-bit device, right? What is the maximum count that we can have with that? 4, right? 2 bits, right? Is 2 to the second. If I tell you this is a 3-bit device, maximum count is going to be 7, right? You follow me on that a little bit? 4 bits, right? I'm just looking at the number of bits that are reserved, and based on that, I can say, okay, this device cannot count beyond that point. So with 1-bit device, you can only count 0 and 1, right? With 2 bits, you can go on up to 3, 2 bits, right? 1 and 1, that's 3 bits. With 3 bits, you can count 7, right? With 4 bits, you can count 15, right? And so the count increases when we look back at numerical system as you have bits available. So the reason they are a word-based instructions, and they have that for the preset and the accumulated, is that if you're in a factory or in a sort of a counting operation, you want to maximize the count, right? I'm thinking about, tea bags in a, huge cardboard box, right? There are probably thousands of those, right? So you want to have that capability on the counter to be able to count up to the possible maximum count. And then when we deploy that count, then we can do what we said last time, which is cascading the devices. We look at cascading with timers, but the same idea is true. So anyways, just a little teaser for you. So we can program counters, and they'll do the same function of mechanical counters. There's a mechanical counter, which you may encounter in some places still, that you reset, and you have, an activating lever behind that. Usually gears associated with that, levers and gears. Every time the activating levers move over, the counter adds 1 number, and then you can reset to 0. And that's done with a push button, usually on the side. So that's a mechanical counter. There's all sorts of electronic counters, and we actually mentioned, I think, and I'll say it again, if you have a controller that is incapable and you have no way to, stretch the counting or timing capability, you can always add an additional module, specialized module that will actually have the ability to do beyond the controller's count. So these are all different types that you can find. So you have up counters, but there's actually applications where you need down counters, right? And others where you need both up and down. Can you think of any applications that come to your mind where this idea of up counters, down counters, and up and down counters can be used? There's actually one up-down counter that we have almost all over the place. I mean, whether we use a controller or not, that's another fact. But think about big cities and parking lots, right? That's how they control. When you go to the airport, you are told how many spaces are remaining. And there's a digital counter when you enter in a sensor that counts when it's full, right? And then when it's decreasing, it's decreasing. So that's an up and down counter. And I think at the airports, they might have controllers or some sort of industrial type of control, right? To control that. So there's all sorts of, keeping track operations. And that's the reason why you want to have a counter. The word bean counter, right? That's no longer the case, right? We don't need any more bean counters because there's all sorts of digital systems that are now able to do that. They're similar to timers, like we said before. And this is how you're gonna set them up. You're gonna have a mode of triggering the counter, right? That will actually respond from false to true transition. And then you have the counter itself. The type of counter, this is an up counter. You have the preset counter value and the accumulated value. The way CCW looks at counter is a little bit different. So you're gonna find that the symbol or the graphic is a little different, but the principles are gonna be the same. All right, so you also have a reset instruction that works in conjunction with the counter instruction. And so at some point that counter needs to be reset, whether that's manually done or automatically done. So we need to reset that counter. Again, way back to my work as a tech person, I was at Pepsi and we use all sorts of controllers, as you can imagine, all over the place. So the production line is, filling Pepsi bottles, right? And then you have counting, sensors and machines. And then, of course, when you're packing, you don't want to have 23 or 24 bottles in a bucket, in a box, right? The 24 pack is what it packs. So there's a counter that counts 24, and there's a way to reset that counter back again. So it happens in fractions of minutes because that thing is packing really good. And it's a robot, actually, what does that work. So block formatted counter, that's more like the CCW is going to look like. Most counters will count on the leading edge, right? In other words, going from the on to the, from the off to the on transition. And that's kind of an important concept. We don't see it, but it is, because what you want to do is trigger something out of nothing to a place from false to true. And so there again, you have a count line, you have a reset line, and you have an output. All right, they can be programmed to count up or down. We said that already. So you're gonna increment one up or decrement one down, right? That's how the counter will count. Here's the limit switch that will be counting, the number of parts that are going through that conveyor. And when 12 or whatever number is counted, right, it does something else, reset the counters and moves on. So that's the counters. There's a block type counter that will go from false to true. And then you can need a trigger event for the number of count. There's some sort of cans that are being counted and there. So it's going to increment by value of 1 each time the count counted event occurs. All right, here is a program that will do that count. You have a push button 1, which is the count. You have the done bit, right, which is a bit that is enabled when the counter is done counting. You have an exclamation close instruction with the same bit. So you want to indicate when it's counting and when it's not. And then you have a reset button PB2 that in this case manually, right, reset your counter. Okay. Here's the counting timing diagram. As the run goes from false to true, right, for that particular counter, that's what happens. Okay, and then it goes and does the accumulated count based on the preset value of 7. All right, here's a little simulated program for the same counter. So notice how it changes, when the done bit enable that pilot light. All right, another flavor of the counter and its associated file, very similar to what we said before. There used to be, I don't think that we can do this on CCW, but the older software will let you up a table. Yeah, now it's more like a tag table that you can open. But on the older software, you open up a table and you can actually inspect or see the actual behavior of the bits on that counter, right? You can see, when the counter is counting up or whether it's counting down, when there's an overflow, right? Overflow means that the counter was triggered by something, but it beyond the set count, right? And then you have the preset and the accumulated. All right, so in short words, we have a count up enable bit, right? That's the CU. We have a countdown enable bit, and they're true whenever the count is up or whenever the count is down. We have the done bit, which is true whenever the accumulated value is equal or greater than the preset value of the counter. That's for either the count up or count down counter. So that's the CU, CD, and DN. We also have an overflow, as I mentioned. That's going to be true when the counter counts past its maximum value. In this case, 32,767. That actually, again, is associated with that 16-bit word value, right? So if that was a 32-bit word, then that'll be a double count. All right, underflow is true when the counter counts below a negative value, right? That's the down counter. The counter will wrap up around to 32,760 and continue counting down towards 0. All right, and then you have the accumulator. This is in conjunction with external high-speed counter. That's a special instruction. You have the preset and you have the accumulated value. So all of those bits can actually be used for whatever purpose you want to enable via that counter. There's a counter up instruction, count up. Its name is C5:0, preset at 10, and uses the counter enable bit. Also uses the counter on bit, the overflow status, and then you need a way of resetting that counter, whether that's done manually or somehow automatically. All right, here is how they used to look. They're no longer this way. We have a little bit different flavor for the menu of CCW, right? This is the RS Logic, one of the older Allen Bradley software brands. But again, the principles of it are the same, right? CTU, count up, CTD, count down, and then HSC, which is a high-speed counter, counting high-speed pulses, high-speed input. And that could actually be an auxiliary module sometimes, and not necessarily a built-in module on the controller. All right, PLC program counter is to stop a motor from running after 10 operations. So you want that motor controlled by this counter to only run 10 operations, whatever that might be. And then you want that to stop or reset. Counter is counting up. Motor is flashing in every step. You can see the counter table. And at count 10, it will reset back to 0. In this case, manual reset, right? With input 2. All right, can counting. So here's a can counting operation. We have a proximity switch, we have reset switch, we have a count up, and we have a count down. And then we have the down bit, which is enabling closing the backs, which is also parallel with a reset instruction. And then we have the count up counter for the packages themselves with a preset, which is again manually established. Okay, that's going to be a while. 300, we're not going to wait. But that's a simulated content operation. All right. Again, you're going to see on CCW a little bit of a different kind of format, but the principles for counters and timers are going to be the same. Here you have tag names, counter type, the style, right? We can also set the style to be binary or hexadecimal. We